Good morning to those of us that have joined already. I'm sure there'll be some more as we go along. My name is Claire Swinford, for those of you that might not know me, and Patty Forehand is joined with me. We both work with the Georgia NASA Regional Educator Resource Center located here at the Museum of Aviation. And we're really pleased today to have Belinda Songer with us, who's worked with us for a number of years, and she's currently teaching high school science at Northside High School in Warner Robins. And so if you've not already gone into the chat box, please do so. We can put our names, say hello, introduce ourselves, and if we will make sure that unless we need to talk or answer questions or something like that, if we'll just keep muted so there's not any background noise going on. And Patty will be monitoring the lobby, and I'm going to be monitoring the chat box. So let me introduce Belinda Songer. Belinda.
Hi, can y'all hear me?
Yes.
Am I echoey somewhere? I can hear me from different rooms in here now. Okay, so as long as everything works right and I don't lose my camera off the top of my computer. And the heat just kicked on, so you might be able to hear that. So this is the Lunar Lander Touchdown activity. And we all know the Lunar Lander activity that we've done for a long time. If you've done any of the NASA lessons about landing, keeping your astronauts in your lander. And we always used to give them all kinds of supplies to build their own parachutes and things like that to slow it down. Well, this time it's different. There's no parachute. It's all about shock absorbers. Well, I teach high school and I've learned to not assume anything. But these kids don't know what shock absorbers are at all. And so I had to go through a whole day of, okay, this is how they work. This is how even shock absorbers in your fancy tennis shoes work. And we had to pull, one of our administrators has a big fancy truck with those very visible shock absorbers, whatever they're called, under there. He pulled it up so that we could go out and look at them. Because the thing that they had in their mind was a spring, which is okay, that makes sense. But I had to bring, I don't know if you can see, this is a spring from a trampoline. Okay, it doesn't work as a shock absorber. I can't even pull it apart, but it works the opposite. So it was really hard for them to understand shock absorber. So we started with, I pulled up some videos and I'm going to show you what I used. I'm going to share my screen. Let's see how this is going to work. And of course I went to the historic, landing on the moon, and we played that, we listened, we heard everything they said, we watched them land. This thing landed with feet and it had a rocket to keep it from slamming to the ground. Okay, I was trying to continue to get the idea in their head that they couldn't float to the ground. So we started building, and I'm going to show you what I used. And here's the lesson. Let me change my page, except I can't see. There we go. The link to the educator's guide, I'm sure it'll be with all this, but this is the JPL's educator's guide to touchdown. It's called Touchdown, and of course that kept sounding like football, so we had to kind of change that a little bit. But this is the Touchdown Lunar Lander activity. That is technically a soft landing activity. You still have the marshmallows as your astronaut. Yes, I had to go through the whole spiel of you can't lick them, you can't cut them in half, you can't eat them, you can't impale them into their lander always. I mean, that was something we had to deal with all the time. But the specifics of the materials is what kind of limits you and makes you think a little harder. So here's our materials. So I gave them, and I tried to stick to this. I didn't, the only thing that I really did change was some of the rules, I guess, at the end, but I'll explain those in a minute. So I gave them one 5x7 kind of, well, it is a 5x7 card, index card, and 3 small ones. And I gave them a plastic cup. Actually, I gave them, not this one. I gave them a bigger one, but it was the styrofoam cups, because I wanted them to hopefully think outside the box a little bit and adjust the size of the cup, and then use some of what they cut off their cup as their supplies. And some of them eventually did. My kids are not used to being able to do things on their own. They are used to being told what to do. Now, this lesson will tell you what to do. Ah, look, she found one a little bigger. Look, a bigger cup. Cool. So I have several sizes. Look, we came up with this one, a little cardboardy, and then we came up with this one. Now, all of these you can cut and change because the usual rules stand. Let me get through these materials and I'll tell you the 3 rules. So index cards, 2 different sizes, 2 regular marshmallows per lander. Regular size marshmallows. So, and I always make them draw faces on them so they won't eat them. Regular size marshmallows. It says 10 miniature marshmallows per lander. Now, my kids thought that meant you were taking 10 of your marshmallow children with you into your lander. No, the 10 marshmallows are for sticking things together or making things maybe have feet or whatever. And then you don't have to use them. You can just, let them dry out and throw them at each other later. 3 rubber bands. I did use these exact rubber bands because that's what school has. These are the kind of like, I guess they call them postal rubber bands. 8 plastic straws. I used these very same straws because I have these coloredy ones. So you get 8 plastic straws. They are the bendy kind. You do whatever you want to with them. Definitely have to have some scissors, and you get 1 meter of tape per lander. Number 1, they had to figure out how much 1 meter was. And I do have a yardstick or a meter stick. Pretty much like this one. Yeah, I think it came from Home Depot. And so they could only have 39 inches of tape. So they would come and ask me, I need 5 inches, please. And then they would write down how much they had. And they realized they needed to sometimes reuse their tape. So we used this tape, masking tape. No glue, nothing else. So our rules are, you have to land softly. You cannot slam to the ground. You have to make sure that your marshmallow astronauts stay inside. They cannot pop out when you land. And you can't cover the top of your lander with anything. And that's our typical rule. When we do landers, even when we did landers years ago, no covering the top. You can't put straws over the top of your guys inside. You can't poke the straws through here and cover them. You have to leave the top open. Now, your top can be anything. Because what if your top ends up being the bottom and you flip it over and you cover this? Okay, fine. I didn't say you couldn't do that. Some of my kids, actually 2 of them, and I do have some pictures, they used this direction and they cut a hole in the top. Fine, that's fine. You follow the directions. Now, I also always tell them, pay attention to what I didn't say, because if I didn't tell you you couldn't do it, then do it. And I had a couple of them kind of push me on that, and I was like, I did say that. Okay, go for it. I have a picture of his too. He did pretty good. This was a sideways lander, and it did have some shock absorber abilities. So let's look at how they have the lesson written. This lesson is written if you want to let them follow specific instructions to do this specifically one way, and everybody's looks alike. You can do that. I don't do that because I don't want them copying off each other. I want them to think, and I want them to create their own ideas. And there had to be a million ideas to get the Apollo to land on the moon. There had to be a million ideas. It couldn't be that, oh, everyone made the same, prototype, and then we did that. So you do talk about, we spent a day looking at videos talking about why it's important for a spacecraft that can land gently when you get your astronauts to and from the moon or Mars. NASA is looking for safe landing sites on the moon. Once they find one, they'll need to design and build a spacecraft that can land there without injuring its astronauts or damaging the spacecraft. Because what if you get hurt or something breaks off? I mean, what if something happens? Who's going to come and save you? So we do in this lesson make a spring out of a index card, and you do it by just folding it back and forth, back and forth. But they still didn't understand how it would be spring-like. And I thought maybe by me showing this to them that they would all do it. Nope. This is our spring. I showed them this. It stayed on my desk the whole time. No one did it. No one used it. They came up with other things though. Some of them took half of their large card, and I didn't use cardboard because it really is hard to cut, but they used this large card and they cut spirals in it so that when you held your cup up, the spirals hung down. And then when it landed, it would land on those spirals, and it did make a difference. I thought, okay, I didn't even think of that. But so, like I said, you can follow the exact instructions, or you can brainstorm, and that's what we did. So they wrote down some of their ideas after we looked at this. Let me see. Shock absorbers, explained and animated in 3D. I'm going to play just a bit of it so you can see. Because we really had a hard time understanding shock absorbers. Not all my kids drive yet. Now we also talk about waves. So this was really appropriate for us. All right, that's my quickie. It'll be linked with that too. These kids, I said, do you remember when you were little and you rode in a little red wagon, someone pulled you in a wagon, and how rough of a ride that was? Because that wagon doesn't have any shock absorbers. They looked at me and said, no, I never rode in a red wagon. So I thought, okay, I have to bring a wagon. I mean, to school, I guess. I don't know. So I had to kind of go, I had to get, I really didn't intend to show them a video, but these are high schoolers that didn't know about a shock absorber. So I have one kid who does actually work on cars. So he knew what it was. All right, so let me go back to our guide. There's our shock absorber explanations. How do you make sure your lander doesn't tip over as it falls through the air? We've had a lot of trouble with that because no one really paid attention that when you had your cup attached to something, because we had a lot of different designs. I had a lot of things that looked kind of spidery. They used these straws for legs, whatever. Some of them, I had one kid, I'm going to tell you, he did it exactly like I did it when I did this activity years ago at a workshop, but it wasn't the soft landing. It was just a lunar lander. And all we did, my group, we took some of these cards, crisscrossed them, stuck our cup in the middle, cut the top out, and it floated like a butterfly all the way. I mean, I think we were 1 story up. So this kid, he did that. He stuck it together. And he put his marshmallows in, and he thought he was cool, and it took him all of 10 minutes. And I'm talking about, this is the kid that never shuts up and never sits down. And we went outside and we dropped it from about a story from the front of the new gymnasium. And it immediately flipped over because his cup was over here. And so he continued to have to work on it just to get it, you know, centered in the middle. And so we talked about not only gravity, we talked about gravity a lot. We talked about balance. We talked about how the air, if there's a little wind or, you know, something, that it's going to affect how it lands. So he thought he was all smart. And I did too. I thought, oh, he did exactly what I did and it worked, but it wasn't centered. So he had to work on that a little bit. So we did test them a lot. We tested them off the table. We stood on the desk. We dropped them in the classroom, and then we went outside, even when it was 28 degrees one morning. We went outside and dropped them, and I have some video. Hopefully I'll be able to show you that and some pictures. It's not that easy, and here's what they said at the beginning. Oh, this is going to be easy. This is so easy. Well, we worked on this for a week. We redesigned for a week. We tried it out for a week. They got very competitive for a week. And when we got done, they were like, that wasn't all that easy. So now they're like, what are we going to build now? Well, we have to do chemistry in my class now. So I don't know how I'm going to work in another activity like that, but they are getting used to being able to build things, and they do remember that there's that rule that says pay attention to what I didn't say. So they want to just build something on their own. So I think I'm probably going to drag all the recyclables in, and we'll be able to do that once we get some, you know, periodic table taken care of. So let me pull us down here. The discuss what happens part. Because I teach in Houston County, I don't know other counties, we do things called CERs. That's claim evidence reasoning. And I have it put into a worksheet. And basically you have a question. It's like a shortened version of the scientific method, even though it came from language arts. Your question is, what was the problem? What was your challenge? Your challenge was to build a lander that landed softly. What was your claim when you first started? What did you think? And how did you think it was easy and you were going to be able to build this? And what was your claim? And then you have to come up with 3 examples of what you did to make it better, the things that didn't work that you had to fix, and then why. What was the reasoning that they didn't work? Most of the time with this, it's either something to do with gravity, something to do with balance, something to do with weight, but they have to make it all make sense, so that if you picked up the CER and read through it, you could understand what we did as the challenge or the build or the experiment, whatever you want to call it. So we've already done Newton's laws, and it's drilled into their head because we've done many NASA activities. We've built rockets, we built rovers, we went outside and tried to knock a football out of the air with another football. We've done a lot of things that you can always talk about. The forces of evil is what they call them. So these questions are, what forces affected your lander as it fell? One of them they wrote in their CER that Miss Songer kicked my rover over with her foot. And actually, all I did was lift my foot, and so they explained that I moved the molecules of air and it blew their lander over. So it wasn't successful. After testing, what changes did you make to your lander? That fits perfectly into your CER the things that you had to do to make it work. Engineers' early ideas rarely work out perfectly. How does testing help them improve a design? These are things that we actually talk about through the whole thing, and they work it out and they don't even know they're answering these questions. What did you learn from watching others test their landers? Well, we videoed it and then we slow-mo videoed it. And that's always really interesting. We showed some of the videos in class so we could look at it and go back out and fix it and then try again. The moon is covered in a thick layer of fine dust. How might this be an advantage or a disadvantage? We've talked about that too. We've looked at microscopic pictures online about moon dust, and we've talked about that before. So the kids want to actually drop their landers again, only in a different environment. So I don't know if we'll get there, but at least they're thinking they want to change the environment. This does come with a rubric, and I did use it. I printed it out and gave it to every student. They actually grade themselves on this, but the issue is it's worded high level. It's like high school level or higher, the way it's worded. So you using it for middle school or elementary school could kind of clean this up so that it can still be identifying a problem, building your prototype, testing and evaluating, but some of it's pretty high level. And that was their grade for their challenge. The whole thing was graded from their rubric. Okay, so here's some extensions. How high can you go? Okay, well, it says 2 feet, and then, you know, increase that. We actually went to almost an entire story because we had the access with our new gym and the stairs and everything. It's pretty high up there. Test springs of different sizes. So we asked the kids, I asked them if they wanted to keep their landers going, if they wanted to bring things from home. So some of them, that's where we are now. We're going to bring things from home that they think might be a good shock absorber. I did make them try the folded index cards. And one of them said that takes all the fun out of it for you to tell us what to use. So, but I did that at the end. So here's the Make an Astronaut lander. This is the page with the pictures. If you're going to talk them through it, here's the tutorial. We recently worked a lot with balloons, and my kids didn't think about, you know, the lander itself. The Apollo lander used a rocket to keep itself from hitting the ground really hard. They now think they might be able to use a balloon and let the air out of it as it's dropping. So that may be where we go from here. We talked a lot about elastic potential and elastic kinetic energy. So here's your supplies, sort of. We used colored straws that bend. We didn't use cardboard. You know, we didn't use Scotch tape. We used something that sticks better, and I didn't have a lot of Scotch tape. It's easier to use masking tape. And there's the list of the materials. So here's the actual lander. That's when we started with our video. Here's your brainstorm. Typically you can work in groups. We're not working in groups right now. Everybody's 6 feet apart. Most of them, even outside, wear a mask. Here's some of the just ideas. Cut the straws. You can cut your cup. I don't care. Keep the pieces. You might use them for something else. And you might want to put them back on, because I had a couple of them decide they didn't want holes in their cup. So they put the little pieces back in there and taped them back in. Here's your actual design on paper. I have a student, and I do have a picture of his, who is very, I guess you could say, type A. He took it home to design it. His mother is a teacher. I think his dad probably is too. So he, you know, he thinks like a teacher. And here's some, this is a, we did this, now I videoed these. My kids doing the same thing, but see, there's always one who's super excited. I have those too. All right, so up until this point, let me see if I've got, I had to open my email to show you the videos. All right, here we go. Let me see if I can pull a video or a picture out of here. This was we had 2 levels of stairs. So we all dropped at the same time. You see how different their shapes are, all of these. We dropped at the same time. No one wanted to be singled out, so we dropped at the same time. And some of them stood up pretty well. Let's see what else came. I had such a hard time getting my pictures from through. This is the student who took his stuff home and designed and then came back and put it together. He's very, he can't wait to do another one, but he's very, I don't know, he's very hard on himself, but he's very creative too. So I do have some pictures of him. You know what? I gotta move my bar so I can see. I'll close that. All right, next page. Let's see my email junk. These are some of the examples of ones that did survive and land upright. And look at this one. Really, ultimately, there's nothing on here that looks like a shock absorber, but it comes down really slow for some reason. I'm assuming it's these long, spindly straws he's got stuck together. It also keeps it from falling over. So that was his focus, was the falling over. I know that if I could have had these kids working together, I'd have had some of these ideas all in one lander. This is everybody working separately. There's our take it home and figure it out kid. And his cup, oh, I can't touch that. His cup is sideways. So it is this way. It has a very large rolled piece of paper under it that is a shock absorber. And then it has straws on the side that keep it from falling over. It's like 2 little U-shaped straws on the side. He covered this end of the cup, and then he cut a hole out the top so that his astronauts could sit inside. I mean, he figured it out. It was pretty cool. Here's another one that landed and stayed upright. And this student, she did like I did, she put the cup inside in the center of a bunch of paper, actually, cardstock. And then she had made sure her cup stayed attached to it. And it did come down very slowly because of the width of that paper, how long it was underneath. And this child happens to be one that hardly ever comes to class. She hates writing anything. She really doesn't participate a lot in class until we do things like this. And then she just does it. And she's always successful. So keeping her busy is interesting to keep her doing things. So, all right, let me move this. Let's go back to Educator's Guide. In the Educator's Guide, I think I know the way. There is such a, there's your overview, your materials, your management, the background. I always like to start with a story. Always. I bring something weird, like this time I brought springs, you know, and you ought to see them try to stretch these springs out and everything. There's always something. So I feel like if you start with a story, they're going to remember. If I tell them something crazy that I happen to, some trivial thing that I know, they remember. And I did have kids tell me that their parents told them that we never went to the moon. So we did spend a lot of time. We spent a lot of time looking for things that prove that we are in space. We spent a lot of time arguing about, did we go to the moon or not? So in the end, I think, you know, because there's so much documentation that the kids are like, well, now how do I let my parents know that I think they went to the moon? I've heard it's a green screen. Nowadays, anything could be fake, but you know, you try to get them to think critically, and then they go, well, I don't know that we went to the moon. Well, okay, we still need to know how to land things on Earth that is not going to kill our the people inside. So, and shock absorbers are a thing. We do use them every day. Okay. Oops. All right, so the addition to this one would be, I would go and allow them to build their, they really so want to build something with a parachute. So I would go and start over, and I'd also make them keep track of the money they spent. We've done this before. Keep track of how much 8 straws cost, or however many you need. Cotton ball, I would add so many things, cotton balls and recyclables, and you know, a cotton ball might cost you $3,000. So they need to start keeping track and seeing how much money it does cost even to build something that you're trying to peddle to NASA or somewhere bigger to work on. So we do that. Eventually we'll do that. And I'm excited to say that physical science does not have an EOC anymore. So we'll have all that extra month at the end of the school year to do things like this again, and to go back and build more things that once we get through chemistry. So if we can build some chemistry things for NASA, that would be great. I gotta do a little digging on that. So if you want to open up the question part, Patty. I think Dawn has a question.
There we go. I was trying to unmute myself, but it's over in the corner, so you know it's never quite right. Actually, when you said that about the chemistry part, oh, sorry, my dogs are in here. Oh, with the squeaky toy. One of the things I do with my kids, because we were talking about the massive stars and the heat and they're the color they are because of basically the chemistry. I actually did burning of the chemicals so that they could see the different colors. It was amazing to me. These kids did not know that things can burn green and things can burn blue.
Right.
And literally it's on Science Buddies, I think it is. It's on their website. But unbelievable how that went over. Like they were so into it. But your kids, you know, they kind of have that same curiosity mine do. So that would be awesome for your kids to do the board.
Well, my problem is I'm not in a science lab, and I can't have any open flame.
Actually, so I got it approved by the fire marshal, and he let me do it in the classroom.
Well, I don't know. I have a kid whose dad is the fire marshal, so.
Oh, they let me do it. He said open flame for just a few moments for them to see the color, and then you're going to put it out and extinguish it. And I was like, yeah, that's it. I'm going to do it, and I'm going to do it 4 times, and then I'm going to let the air clear for a minute, and then I'm going to do it again so they can see it one more time up close and talk about it while we're looking at it. And he was like, I don't think that'll be a problem. Go ahead, just make sure the fire extinguisher is handy.
Oh,
and I was like, yes. So I pulled the fire extinguisher and stuck it by my table, and we burned them, and he was fine with it. I was a little afraid he was
have to check, because I'm in a carpeted room.
Me too.
And the smoke sensors are in my room because it used to be the end of the building.
Oh.
So, but I can move. I mean, I can move. I can throw somebody out of their science lab.
Yeah, any place you can get dark will work. And I actually have spare chemical, you know, I mean, you only use like a few granules basically.
Yeah.
So, I mean, I'm happy to loan it to you and let you dip your, you know, your skewers and get them made and all that good stuff.
Mhm.
I was shocked at what the kids didn't understand about what we were doing with the stars. Like, you talk about mass and they understand the mass varies and all that, but they don't really get that until you get into that chemistry a little bit. And then they're like, whoa, what happened? Why is it doing that? And then they turn on and start really looking. But it was something new I did this year, but it's straight up chemistry.
Yeah, well, we got to get through the periodic table. We're kind of working on uranium glass right now. But then I have forensics too. So forensics, I do the same thing. I mean, we're still looking at the periodic table and forensics and breaking glass, which got me, the janitor visited my room and went, "What are you doing?" I'm like, I'm trying to keep
real
it
bad.
all
I just put a note and say, don't come in. We got this. We'll clean it up. Then you can come. We don't let him in if we're going to be bad.
Well, this was a little different doing this just because they had a limited number of supplies, like specific supplies.
Yeah. Now, why did you choose to not give them pipe cleaners? I did notice that because I always let my kids have pipe cleaners too, but
it's not on the list.
Yeah, nah, I usually let my
We
kids
stuck
have
with
them,
what
but-
was on JPL's list. The straws that I used do bend, and it didn't say that we couldn't use the bendy straws. But we stuck to the list, the things that they have on there. And then, you know, like I said, if you want to extend it and go, okay, now let's try other things. And I do that in forensics too. We do some of these things. We did, you know, the activity where you build a hand, you know, the, what's it called? The Canada arm activity where you, it's actually a hand with fingers that move and you pull the strings.
Yeah.
We did that. We do that for forensics, and kids brought little tiny springs from home, and I don't know where they got them, but he did that so that his fingers, he could have more pull on the fingers, and so that the fingers would be more flexible. I kept that one. I have that one from last year.
Yeah, I would have to.
But I haven't done that in forensics yet, that one, but we do do the Canada arm activity in forensics.
Yeah, what do you use for the cardboard part of the hand? Because last time I used the index cards from the county, they bent so badly.
We use regular cardboard or cardboard like you get from a shoebox.
Okay. So maybe they're treat boxes with the granola bars and stuff. That might work.
we did. It's pretty heavy, so they could, you know, and then we cut the straws, you know, to run the cotton. We used cotton yarn, I guess, to go through them. But he didn't like that when you pulled it to you, it didn't come back. You know, the strings, eventually you do it too many times, the hand stays kind of curled.
Yeah, you get the claw.
Yeah, he didn't want that. So
that's interesting. I wonder where he got the springs, because I'd love to see what my kids would be playing with the springs.
They were bigger than the kind you get out of a pen. But now I'm gonna tell you, he did work at an auto parts store, so it could have been something from there.
Yeah. Yeah, because that's where I got my steel bearings that I use in my classroom. Was when they rebuild engines, they just chunk the bearings into a discard pile and sell it by weight. And I just said, hey, you know, could I have some of those? And they brought me a whole tub of them, and all I had to do was clean them, you know, get the oil off from them, and they were perfect. So yeah, he might be using a discard bin or something.
Mm-hmm. Yeah, he probably is. All right. Any more questions? I think it's just us, isn't it?
I think it is. I think it's just us.
Mm-hmm.
Well, I don't know our gentleman with us. I don't know him. But
yes, Kurt had chatted and said that he had to leave, and thank you very much. He appreciates the idea for the project and enjoy the presentation. So he just had to leave. And we do have another person with us. And if there are any other questions, please unmute yourself or put anything in the chat, and we'll be happy to just chat amongst ourselves right now.
Well, you sparked a good idea for me, Belinda, because I realized in the midst of listening to what you were saying, because you made the comment about the budget. And one of my kids, literally, when we did the race cars, he walked up and he said, "Are we going to have to do that crazy budget thing?"
I know.
They don't want to do the math. It's hysterical. I mean, I didn't make them do it on the car because I wanted them, I had them build like I built so they could learn the dynamics and how to use, and have them engineer after they built. Because, with 7-year-olds who are a little bit immature, sometimes you have to build to the model and then explore from there, depending on the kids.
Well,
one of those crews.
I have 11th graders and they're no different than 7-year-olds.
Yeah, kind of sounds that way some days.
They're not.
But I love when you started talking about it, I thought, shoot, I can have them build a high hide and use the pulleys because we're in the middle of Newton's laws right now too. They've got the general idea. They just need more experimentation to get it locked into their bodies, what it is. But if they design and build their own high hide in a tree, that would be awesome. And I think I can probably make a tree out of cardboard so that they can't damage the tree when they're building it either. So they can get so much weight on it that it won't, that it'll tear up that it would tear up a real tree. It's got to be feasible. And I'm thinking, oh, that's a good idea. And I could do it right along this same model, just, different thing. What can I say? I went from springs to pulleys just that quick.
Yeah, we usually, our first semester is all physics and then the second semester is chemistry. But now they're like, what else are we going to build? I'm like, okay, let me see. Let's make something up. I don't know.
That's
chemistry, we got to do periodic table.
Yep, that's what happened to me. And that's why I'm going to be doing a whole lot of thinking over the weekend while I'm working on this because I said, well, what do you all want to do for 100th Day? And they're like, let's do something different. And I was like, okay, we're reading about gorillas. What do you want to do? And they came up with this whole big idea. And I'm like, okay, but we need activities that you can learn. They're like,
Is that what you were talking about earlier, Jurassic Park?
Yeah, but we do Jurassic Park in March, and that's already kind of set. We have all the mapping skills and the coordinate planes and all that stuff built into that already. And we do the owl pellets with that. So we do a lot of, because we use it for life cycles unit plus some other stuff. And so I don't want to touch on that because that's kind of a team thing the whole team does. And
so you're looking for something with gorillas?
Yeah, anything with gorillas. I thought about doing like the petri dishes and growing some germs and looking at them under the microscope, because I've got the electronic one I can put on the petri dish.
What about Bigfoot?
Ooh, that's good.
What about like doing footprints of different kinds of primates and humans and then the Bigfoot footprint?
Oh, that's a good idea.
Because there's a lot of stuff on YouTube now of people who actually, not that crazy show that Bigfoot hunter show that never found anything. No, the history of like the old people who talk about it and the Indians who talk about it and the, because that story is something from every country has a Bigfoot. It might not be called that, but every mountain area has a Bigfoot. And we're considering talking about it in forensics because we do prints, like we do footprints, shoe prints, and tire track stuff. But when you walk like in the sand, your footprint isn't flat. It's not like you're standing still. It's the toes dig in, and the ball of your foot digs in. So some of those footprints that they found, supposedly of Bigfoot, right, and poured the plaster, are just flat footprints that somebody took like a cutout and just pushed it into the ground. It wasn't something that was bipedal and moving forward.
Yeah, that's a good idea.
And then there's some clips of that old movie about Bigfoot who lived with the family. There was that show on TV one time.
Yeah, Chevy Chase, I forget, yeah.
I mean, there's some clips, silly stuff like that.
Hendersons or something, yeah, that one.
Yeah, Harry and the Hendersons, yeah.
Yeah, that's a good idea. See, it's not as easy as it sounds to do this, is it? I mean, I pulled up the satellite images and I thought, well, this is cool, but what are we going to do with them? Because they're 7.
Well, and
I was like,
so-
well,
and they are still, if you can find, I'll have to look too, they are still finding different, I guess, species or kind of primates that we never knew about.
yeah.
So,
I figured we could touch on the diseases and the fact that tourists coming in are making troops of gorillas sick, you
Yeah.
know, and that kind of fits the COVID right now and reminding them, you know, wash your hands, keep yourself, you know, the stuff we have to do daily with the kids anyway. But I also was thinking about, you know, I am going to go ahead and hit on the poachers. I'm not going to let them see any of those images. They're graphic. They're unbelievable. But we are going to talk about the poachers, and I'm going to do some robotics with that and have them program the robots, and then they'll flip the card and the troop is going to move somewhere on the grid. And then they have a poacher coming in who only has 4 moves, and the reserve officer who can have 5 moves, but programmed to try to keep the poachers from getting to the troop, you know, trying to head them off. And it gives them a little bit of advantage, but then they are 7 and 8 too. So
Right.
some of the smarty pants will record Dash going, stop or I'll shoot. You know they're going to do something crazy with that 5th step they have, and they're not going to actually use it appropriately anyway. So, but I'm thinking of a cat and mouse game with the robots too, letting them work that. But other than that, I'm a little bit stuck. One of my parents suggested maybe doing some of the water purification stuff I normally do with Jurassic Park. And I don't think that's a bad idea because I think I'm the only one who does that with Jurassic Park. So it would be okay for me to move that out without bothering anybody else's, you know, without messing up any of the other teachers. So, but other than those things, I'm kind of stuck, you know, and I don't really want to give them like just, you know, here's your math worksheet. There was so many gorillas doing this.
right.
And, you know, I don't want to give them like the normal. I really want it to be real world. But that is not as easy as it sounds to plan.
Mm-hmm.
So I was like, well, brainstorming's a mess because I threw it out to the team and I got 4 teachers back going, I'm just burned out. I can't. I'm like, okay, well,
Yeah, and this year, just
I get
because
it.
of the way things are in our schedules, we all have the same planning period. All of us, the whole school. So we
Wow.
don't, and we don't have enough subs to
Yeah.
take a day for planning. Every semester we get 1 whole day with your department to plan. We don't have that because we don't have enough subs. So I think we're staying after school one day.
Yeah.
But
See, in my team, I can't, they're just literally closing the door and surviving. They're not really trying to, they're
you
just
guys
not
have
putting a
online,
lot of
you
effort
have
in.
online kids too, right?
We do, I'm the only one who has online in my room and kids at the same time. We have a digital teacher who does all the rest of the online kids. But the gifted kids actually come online with me if they're at home, and I just have the camera in the front of the room.
Oh,
and, you know, screen share. It's not perfect,
Yeah.
but it gives them the extra stuff that they need that they wouldn't get if they were just in the other digital class.
Yeah,
So-
I have that too. I have physical science online, but high school kids don't get on.
Yeah, see, mine get on because their parents, you know,
Right.
make sure they get on. But the thing is, they have so much trouble, you know, because elementary class, I don't know about high school, but elementary classrooms are loud. The kids are moving around, they're talking, they're banging, they're falling out of their chairs.
Yeah.
You know, I mean, just, you know, normal little kid stuff. And so they have a hard time hearing on those cheap cameras that they stole from the high school and put in our building for us to use.
Yeah.
They, you know, I'll see my kids online on the screen going, what?
Yeah.
And what it is they can't hear anything but the ambient noise in the room.
Yeah.
And, you know, once I get everybody else, I'm literally going, be quiet. They can't hear, shush, you know, and then I try to teach. And by the time we've done that, we've totally lost the momentum of the lesson, you know, and then discussions, if we're having a discussion, they can't hear what the other kids are saying. So then once Tony starts talking, I have to repeat word for word what Tony said and then throw it back. So it gets very arduous by the end of the day. You know, by the end of the day, I'm exhausted trying to deal with all of it at the same time. So, you know, and then
Do
every
you
time
have
somebody
to-
quarantines, we have them online too. So then we got crazy with that. So.
Do you grade your online stuff?
Yeah, if they're legitimately working online, we do grade it. And I can boot them over to Kreitzer, who is our digital teacher, if we're not doing anything that they can really do from home. I've been, because it's only been a few kids at the time, quarantined or whatever, I've been trying to just put little kits of stuff from the classroom together that they'll need and dropping it on the porch, you know, and I just drop it on the porch and back up and let them get it. And we've been doing a little bit of that. So all of my kids could do the same activities, but you know, they don't have the partner there to talk through, because we've got I made my own. I took the plexiglass stuff they got us and I bought some PVC pipe and I made my own dividers so that they're more kid friendly. And they can sit there and talk through that divider and work together on things and manipulate it and still each make their own, but they can talk freely without it being a problem and collaborate. So, because we just keep our mask on all day. So it's working for us, but, you know, and then we're allowed to let them work together for 10 minutes at the time, but then they have to split apart. So if I have stuff I want to do, like yesterday, they did the reaction rockets, because we're still working Newton's laws from every direction. They were doing the reaction rockets, but somebody's got to hold the ruler while somebody else drops it, and you've got to be able to watch it to see how high it actually reacts. And so literally, I just put them in partners because I can do that and get away with it. And then at 10 minutes, I'm like, split it up, look at your data, let's talk about your data. Okay, back together, finish up. We just kept doing that every few minutes until, you know, we got the activity done. It took a lot of time, but it was a good activity. It worked. It just, you know, what you don't see in the pictures of the kids working is how I have to keep stopping and going, okay, that's 10 minutes, split it up, you know, go back to your spot, you know, and do something different for a few minutes. And it kind of breaks up the day in places I don't really want it broken up. But,
you know, something else before we have to stop recording, something else that I thought of for your apes and stuff would be the sounds they make.
Oh,
You know, they're all different. And some of them, you remember the gorilla that they taught sign language?
yeah, Kiki or something like that. Yeah,
Coco, yeah.
Coco, that's
They
it.
could never, gorillas don't have the ability to make verbal, like too many verbal sounds, like they could never learn to talk, right?
Right.
It was, that's the changeover, that's the difference for us and them. Is we have that control and they don't. But, you know, then there's the, you could pull up a clip of the Umbrella Academy, and the butler of the Umbrella Academy is the first chimp that went to space. Do you remember when, was it Russia that sent a chimp to space, or was it us? In the very beginning?
I think it was
Well,
Russia.
it's that chimp, supposedly, because the Umbrella Academy series always follows historical guidelines for some reason. It's such an interesting show. It's not little bit kid friendly, but there is the chimp that went to space. Of course, they say he came back and he was injured or not healthy in some way. So they did some special DNA manipulation to him to get him better. And he learned to talk. And so he grew up a little bigger than he was, and he became the butler of the guy with all the money, and like a big round part of the family. But he was a chimp that was able to talk, which can't happen, you know, I guess, unless you're manipulating his DNA. But
but it goes along with Ivan, because Ivan tells the story in the book, even though gorillas can't talk, he tells the story.
Right. Right.
I haven't watched those, but I'll have to get them and pull them up.
I think it's Netflix or Hulu. You need to watch.
It is.
Umbrella.
I've seen it.
Yeah,
I just thought it was like a kid's show. I didn't realize.
No, it's a grown-up show. Okay, it was initially a book of comics. It's like a comic strip, But the guy who wrote it is a musician. He's very creative. It's insane.
Oh,
You got to
okay.
watch it, and then you'll have to watch the second season
Okay, yeah.
because
I can
it's
do that.
historic. Have you seen that one, Patty? The second season
Yeah.
about Kennedy.
So that's a good
Anyway,
idea.
it's 11 o'clock.
Awesome. Thank you.
All right. So are there any other questions or anything before we stop our recording? Is that it?
I think we're good.
Well, that was wonderful, and we sure do appreciate all of you coming. All right. I'm going to end our recording.
See you later.